Hello everyone, this is the circuit of a capacitor discharger, which is non-polarized, meaning you can put the capacitor on either way round and the meter will still read the same way. That's due to the bridge rectifier being used as steering diodes, current steering diodes. The discharge resistor is the 5 kiloohms at 100 watts. Now that is slightly overkill, but it will get warm actually if you're discharging capacitors in quick succession at say 500 volts. This device is designed to do a maximum of 500 volts. There's also, for added safety, a voltage dependent resistor put across, which is there to well, it'll blow the fuse if you should exceed the rated voltage, and it'll hopefully save the meter and the bridge rectifier. Although the bridge rectifier has a PIV of 1000 volts, so it is well within the capability of it. The fuse, as you could see, is 200 milliamps. I couldn't get 200 milliamps at a high voltage fuse, so I had to get a 500 milliamps, which should be sufficient. It'll just allow a little bit more current through before the fuse blows, that's all. But it'll still do what it's supposed to do. So now let's get on to constructing the unit. I've done all the preliminary drilling the holes in the case and so that things fit into it, and I'll show you all the little sub-assembly and the assembly work of this capacitor discharger. Here is the sub-assembly. It carries the bridge rectifier, the voltage dependent resistor behind it, and the preformed wires cut to the correct length and shape in order to assemble this capacitor discharge circuit. As you can see, I've cut the hole for the meter to fit through, and 2 elongated holes for the 2 terminals to fit that the test leads go into here, and there's holes for different mountings that go inside, as you'll see as I assemble it. Right, I'm going to fit the meter now. So here it is. We put that in there like that, and it drops straight in like that. Now in the back here, there's 2 mounting bolts that you put the washers on. Two spring washers. And 2 nuts. The reason I fitted the meter first is because when I put this chunky resistor in, it's going to be difficult to get to that nut there. So I put the meter in first. I've got paper on here that the meter face will rest on and make sure there's nothing on it, so as not to scratch the glass, the front, well, it's not glass, but the fascia. Now I'm going to fit the chunky resistor. Now I'm going to hold it slightly away from the edge of the plastic with washers. So what I'm going to do is I put these through here. These are plastic, by the way, but they're very high temperature plastic, so there's no risk of it of them melting under normal temperatures. With a washer on the other side, again, one goes in there. These holes are not quite big enough, are they? But that's it. Again, washer goes on. Again, this goes in here, and that one goes in there. And hold them all whilst, if I can get it down there, push those through the holes. That's it. As you can see, it's gone in like that. Now I'm going to put shake-proof washers on these as well, because I can't do these up very tight because the plastic threads will strip, but it will stop them. I seem to have not got enough nuts out. Oh yes, I have. There they are. So that, another washer. Like that. Now these are going to be slightly more difficult down here. That one's on. I'll get that out in a minute. So, right, now we have the resistor fitted. As you can see, it's rigidly connected to the box. Now I'm going to fit the terminal sockets. Now you'll notice I've got two red ones here. The reason there's two red ones is because the unit is non-polarized, and I thought the red would show up better than the black ones because they come in pairs of red and black, and I could have put two black ones in. I thought, no, I'll put two red ones in, so that's what I'm going to do. One in there, one in there like that. Put these washers on. And this washer here. Put these nuts on, making sure I don't cross thread them. This one on here. making sure they're properly aligned. There is a little bit of leeway on these. You can adjust them slightly if you want to, if they're not quite in line. I think they're okay now. Yeah. I don't know how I'm going to do that. I don't know. Yes, I can. Right, that's the terminal fitted, where the two leads plug in. They're the safety ones. They're rated up to 1000 volts, so everything's very safe and safety conscious here. I'm using plastic bolts throughout so that there's no metal that sticks out that anybody could somehow get a shock off it. Not that they should do, but it's better, and also it blends in with the case as well, of course. Now this is the sub-assembly, and once we put this in, I'm actually going to put the fuse holder in first, because I just remembered there's this lead here on the sub-assembly passes over the top of the connection to the fuse holder. So rather than put this in the way, I'll put the fuse holder in first and wire it up, and then I'll put the sub-assembly in. As you can see, I've mounted the fuse holder, and the pre-formed leads go exactly onto where they're supposed to. From this lead it goes through the fuse over to this resistor. I will now put the sub-assembly in, and here is the finished item, fully wired up. All I've got to do now is put a fuse in there, which I've got, and I'll give it a test, see if it works. As you can see, I've now put the fuse in. It's a 500 milliamp. I couldn't get a 200 milliamp one, so I've had to use 500 milliamps. It should be okay. That's more than adequate. And here is the completed unit. Including rubber feet on the bottom. And here once again is the circuit for it.